The challenge that was given to us by the automotive makers is to invent a new steel that has high strength but high formability. In other words, you can bend it, you can form it, and when you do that, you can actually use less material because it's higher strength, and you can make more complicated shapes. We were successful in doing that. We call it Fortiform 980. It's part of the third generation of advanced high-strength steels.
The coil comes to the line. It is then welded to a coil that's already in the line. So the process can continue in a continuous fashion with a more or less uniform, constant line speed. So that makes everything stable. The process can respond slowly to changes that may occur. After you reach the peak metal temperature, or the maximum temperature, we then cool it. And then, in this unique process that we have, we then heat it again to a lower temperature and hold it for a little period of time. And then we go into a liquid metal of zinc.
So in this process, what happened is we casted the slabs in ArcelorMittal, Mexico, and then they have to be subsequently processed in Calvert in Alabama. The problem and the challenge that we had were the slabs were cracking in the process of transportation or on their way from Mexico to Calvert plant, and our challenge was to make sure that these slabs are not cracking, first of all during cooling or their production, and also during the transportation. So that's where global R&D comes in to play, and we took up to the challenge, and the team here at East Chicago Global R&D took it very seriously. We were very successful in reducing these cracks, and bingo, the product is successfully transferred to Calvert.
This particular product poses a huge joining challenge, a welding challenges, and we have to develop the correct welding parameters here that the plants will have to use in order to produce the product. If you ask me, I would say this is one of the biggest accomplishments of the team, is to be able to pass this product through the line by coil joining it.
This is the big driving force for everything that you see now in the automobile industry. We have to reduce weight. We really don't have a choice. We have to reduce weight to meet fuel economy. At the same time, we have to provide the best crash performance. Not just that, going forward, it's our responsibility as a company, as a community, to make sure that the pollution, the greenhouse gas emissions go down and keep going down. And this is our way of doing it. Okay, if you want the car to meet the performance, you need to use these steels, which are a combination of good ductility and good crash performance. But this trend of having to meet crash performance and at the same time get the greenhouse gases down is here for us to stay, and to stay for good. This is critical that we do this.
I think the whole innovation society is really unique to Northwest Indiana, and it's quite an honor to be invited to be a participant in it.
Naturally, I'm not a native English speaker, and neither I'm from Northwest Indiana, but it does actually fill my heart with joy to see this recognition coming from a local community where we have this research and development located in, and I'm really, really proud about it.
We are ArcelorMittal, and we are Northwest Indiana Innovators.